Hi, statistics. This is chapter 1 homework. So what I want you to do is I want you to notice a couple things. There's 30 questions. So you're going to see a total of 30 questions, and it's worth 30 points. So we do want to make sure that, so each question is going to be worth 1 point each. So the first question here, determine whether the source given below has potential to create a bias in statistical study. It's going to tell me a certain medical organization tends to oppose the use of meat and dairy products in our diet. That organization has received hundreds of thousands of dollars in funding from animal rights foundations. So the question is do we think that there's going to be a bias? If you're not sure what a bias means, come over to question help and click on textbook. So what's going to happen is when I scroll through my first time through, I'm just going to look at anything that has this shaded background or on the side here. So these are definitions, but I don't see bias. I also see origin of statistics. And then if I go up here, this arrow, next page, this is going to give me different statistical thinking. And if I go through again, value of statistical life, there's another definition. But then over here, look what I see, publication bias. There's a publication bias in professional journals. It is the tendency to publish positive results, such as showing that some treatment is effective much more often than negative results. So you see how on the left here, I found my definition of bias. If I go back to my question, do I think that there's going to be bias here? Certain medical organization tends to oppose the use of meat and dairy products in our diet. And that organization received hundreds of thousands of dollars in funding from animal rights foundations. There definitely appears to be bias. There does appear to be a potential to create bias. There's an incentive to produce results that are in line with the organization's creed that is of its funders. So where the money comes from. And so that's going to be my answer there. On the next question, determine whether the sampling method described below appears to be sound or is flawed. In a survey of 578 subjects, each has asked how often he or she watches TV. Survey subjects were internet users who responded to a question that was posted on a news website. So where do we think? So how often they watch TV, and it was posted on a news website or internet users. So this is flawed because it's a voluntary response sample. So what's going to happen is you're not going to always have all of the people. So if you're only asking in one particular place, i.e. internet users, and it's posted on the news website, if they also posted it on their TV show, or they went to, did a mailing, then it's still a voluntary response, but people are going to tend to respond if they feel very strongly either way. So it's flawed because it's a voluntary response sample. In a study weight loss program, 35 subjects lost a mean of 2.3 pounds after 12 months. Methods of statistics can be used to show that if this diet had no effect, the likelihood of getting those results is roughly 3 chances in 1,000. Does the weight loss program have statistical significance? So does it have? Yes, because the results are unlikely to occur by chance. Because here, 35 subjects lost a mean of 2.3 pounds. It's only 3 in 1,000. That's 0.003. So what we're going to find is statistical significance is going to be at 0.05. And then does the weight loss program have practical significance? No, someone starting a weight loss program would likely want to lose considerably more than 2.3 pounds. So as we go through, some of it's going to be things that we have to learn from the book, but some of it you don't want to read into statistics questions too deeply. So here's another good question. Under question help, just help me solve this. So as I go through, results are said to be statistically significant if they're unlikely to occur solely by chance. Is 3 chances in 1,000 generally considered to be unlikely? And so when you answer that question, it's going to ask you, questions along the way, and it will step you through step by step. So some of your other questions, how do a parameter and a statistic differ? One of the things that you want to know is that parameters and statistics are both going to be numerical. And then a parameter is going to be on a population. So parameter, population, they both start with P. They're both numerical. Statistic is going to be based on a sample. They both begin with S. So that's one way to remember the difference between a parameter is numerical measurement of a population. Population is going to be what? The entire group. Statistic is numerical measure of a sample. A sample is going to be a subset. Another time we're playing on that letter S. So here's another one. I went into question help and I clicked on textbook. And definition, I had to go forward one page. Parameters and numerical measurement describing some characteristic of a population. Statistic is a numerical measurement describing some characteristic of a sample. So this is one, if I clicked on that textbook help and I went forward one page, right in that shaded box, you want to look for those bold and you want to look for shaded boxes. The next group of questions are going to ask you to determine whether the given value is a statistic or a parameter. So it tells you a sample of 2,032 men showed that 38% go to school. So it's a sample. So if it's a sample, is that going to be a parameter or a statistic? It starts with S, so it's going to be a statistic. And then the next question is which of the two? Because the value is a statistic because it's a numerical measurement describing the sum characteristic of a sample. So that's going to be my answer. So here's a good question that's going to show you lots of different question help. Determine whether the given value is from a discrete or a continuous data set. So discrete is going to be things that are countable. 1, 2, 3, 4, 5. The number of cars, the number of trees, things like that. Continuous data gets more into weights. So when a car is randomly selected, it's found to have a weight of 1,844.4 kilograms. And so this is going to be continuous because the number of possible values is infinite and not countable. And so in my question help, we have help me solve this. We have view an example. We can see a video. We can see animation. We can also go to the textbook. And so all of those are going to be great help in order to solve this particular problem. So I clicked on my textbook again. You could do any of them. You could have used the video. You could have helped me solve this, show me an example. Discrete data is going to be quantitative, and the value is finite or countable. And so that's where we're counting things. And quantitative, think about quantity. So think about numbers. Continuous is going to be infinitely many possible quantitative. So again, quantitative, quantities, numbers. So the other thing is if I scroll up a little bit here, is we are going to have quantitative or numerical data. That's going to be numbers, quantities and numbers. Categorical or qualitative attributive data. So qualitative, categorical is going to be qualities. So that's going to be hair color, eye color. I can't take the average of blue, green, or hazel eyes. So that's going to be categorical. That's going to be qualitative data, different qualities. On this problem, if I clicked on view an example, it's going to give me discrete data definition and a continuous data definition. And then the possible values of gears, because it gives me a different problem. When a bicycle is randomly selected, it is found to have 18 gears. So this is going to be what? This is going to be, it's countable. So if it's countable, it's going to be discrete. So another group of questions in here is going to ask about determine which of the 4 levels of measurement, nominal, ordinal, interval, ratio is most appropriate. So this is favorite types of music. But if I go to my textbook, then what's going to happen? So I went to question help, textbook. It's going to tell me levels of measurement. Nominal level of measurement. So the nominal is going to be name only. So nominal, name. So nominal is going to be name only. There's also going to be ordinal, and so they can be arranged in some order, but differences obtained by subtraction values cannot be determined or are meaningless. And so something like this is going to be ordinal examples, course grades. So what's going to happen is I have what? Order matters. My course grades. Does it matter if you get an A or an F? Absolutely. So course grade is going to be ordinal because order matters. There's also interval data. They can be arranged in order, and differences between data values can be found and are meaningful. Data at this level do not have a natural zero starting point when none of the quantity is present. So years is a great example of interval data because does it matter if someone was born in 1976 or 1988? Absolutely. So that matters, but does the year zero really mean no, it really doesn't. Temperatures is the other. 98.6 is that average. But if someone has 100 versus 105 fever, that's a huge difference. But zero doesn't really mean as much. Ratio is going to be where there's arranged in order, differences can be found and are meaningful. The natural zero starting point where zero indicates none of it. So the length of cars, class times, those are going to be good examples of ratios. So by going to my question help and textbook, it gives me a lot of information. So favorite types of music, nominal, that's name only. I hope that this helps a little bit. There's a ton of questions in here. If you have any other questions, definitely question help can get you a lot of information. Please also feel free to reach out to me and I can help you as well. Good luck with chapter 1 homework.